Hello and welcome everyone. My name is Professor Brian Hutchison and I'm a math professor here at VC. Today we're going to talk about some simple fractions. And we kind of like to always call them proportions, but there's some neat things that they do and there's some neat rules that we can apply that can sometimes save us a little bit of time. So let's just start off with something that's nice and cute, that we know to be true. So 2 over 5. Well, what is this guy equal to? Right? If I multiply the numerator and the denominator both by 2, I get that this is 4 over 10. And one thing we can do to check that these two things are equal is something that y'all, as students, usually completely know and love, and it's cross multiplication, the butterfly method, etc., etc. But this and this, so the 4 times the 5 has to be the same as the 2 times the 10. Of course, this is 20 and this is 20, and that's a true statement. That's a true statement. But I just want to talk about what happens if I can manipulate this guy any. Right? So if I can use this cross multiplication as a reference, and that's something we believe, we know, we trust. What can I do to manipulate some of this stuff? Well, the first one we should try is on the diagonal. What happens if I flip-flop these? And what I mean by that is the 2 and the 10 change places. The 4 and the 5 change places. Is this still a true statement? The answer is yes. 2 times 10 is still the same thing as 4 times 5. And that has to be true. Would that work if I had to solve? So let's say I had a problem. So we know that 1/2 is the same thing as 2 over 4. Right? Everybody agrees with that. But what happens if I put a little x right here? An x in our denominator in an equation, it's usually something that we have to deal with quite often in all mathematics, 300 all the way up to calculus. And I'm just saying, is there an easy way I can do this? College algebra says I should multiply through by a least common denominator to get rid of those x's and the 2 on the bottom. So I know we can do this in our head, but look what this last thing does. It says I can put the x over on this side and the 1 down here. And then of course when the 2's change spots, I get this thing. You might be saying, Brian, that still doesn't look very good, but I can get rid of division by 1. What number, when divided by 2, spits out a 2? Oh, x has to be 4. Hey, I get to do it. So does it work if I only switch one of the pairs? So let's do 2/5 is equal to 4/10. Let's see what happens if I only switch on the diagonal. This will get me 2 over 4 is equal to 5 over 10. That's a true statement also. 2 times 10 is still 20, and well, 4 times 5 or 5 times 4 is still 20. This is a true statement. I don't have to do both. I can just do one. But for that one, I'm just going to go back over here, right? 2 with a 2, that's just easy peasy, right? I don't have to switch the 2 with the 2. So we can see this exact same problem is only switching the 1 with the x on the diagonal. What else could we do? Do we have to switch at all? Think about that one. Do we have to switch at all? So if I start with 2 over 5 is equal to 4 over 10. This is all built on the fact that 2 times 10 and 5 times 4, they both give me 20. Well, what's another way I can multiply by two numbers together to get 20? 1 times 20, right? So I picked on the 5 and the 4 last time, so on this one, let's push just the 10 up with the 2. So 2 times 10 would give me 20. Now mind you, I'm going to write this in blue. We're not leaving a 0 down there. There's technically a 1. 1 times 20 is 20, and 5 times 4. But is 20 divided by 5 a 4? Because I really don't want to write that division by 1. And the answer is not just yes, but heck yes it is. Right now is where you start to get those little goosebumps, right? Something neat's going on here. Something neat is going on here, which means if I go back to our little example problem, so 1 over 2 is equal to 2 over 4, but let's just say I didn't know that. Let's say I did not know that. If I can push one side up, I should be able to push the other one up. So this guy goes over here, and I can just push that guy over there. X times 1 is X. 2 times 2 is 4. So that's all I did, is I just went in one direction to go up. But this is where our cross multiplication comes from. Basically, we just did cross multiplication. But I'm just using it in different rules with basically a fraction is equal to another fraction. This proportion idea. So if you've caught on, I'm really not going to do too much with proportions. I want to just show you nice ways we can manipulate these types of problems. But in the end, they're proportions. And we get to have fun with it. So now comes the crazy stuff, right? So still using my original one, 2 over 5 is equal to 4 over 10. What can't I do? So in red, I'm going to say, can I switch a denominator with a denominator? So 2 over 10 is equal to 4 over 5, and no. Right. 2 times 5 is 10, 4 times 10 is 40. That I didn't keep the proportion going alive. Right? I did not keep it nice and neat. So the answer is no, we can't do this. It's all about the diagonals. It's all about the diagonals. Now, are there other things we can do? And the answer is yeah. But it's all about that diagonal. So let's do a problem. A little higher up problem. And I'm stealing this from some of my favorite inverse problems. If you're in Math 0300, you don't have to worry about knowing what an inverse is. But I just want to tell you, I want to solve for y. And how I see students dealing with this is they say, well, we don't want the fraction, so we multiply both sides by y plus 3. Nothing wrong with that. These cross out, leaving me a 2 on this side. I usually see distribution xy plus 3x. We want to solve for y. So then they subtract 3x, and I get xy is equal to 2 minus 3x. And then I want the y all by itself, so we divide by x, and I get y is equal to, so the x on the bottom wants to divide each of the term in the numerator, so that'll be 2 over x minus 3x over x. Basically, I have fractions with a common denominator, and we get to push them together, but I also get to rip them apart. That's this method. The x's cross out. I think the best thing I could ever do to simplify is to get it looking like this. That was a lot of work, multiplying through by my LCD. Right. A little distributing, a little bit of other things. Technically, I didn't have to distribute my x into the y plus 3, but I see a lot of my students do it, so I did it. So what if I use this idea of a proportion? And in blue, I just want to remind you, this is divided by 1. Well, one of my rules says on the diagonal I can flip-flop these things. So the y plus 3 can come to this side and the x can go to the bottom. So instead of getting stuck distributing, I basically just immediately divide through by my x. Oh, how do you get rid of a plus 3 minus 3? I am not using voodoo. I am just using some of my little rules about proportions. And it just works out really, really cute, folks. Works out really, really cute when we have them, right? So remember, if I have a fraction is equal to a fraction plus or minus another fraction, that's going to be, I can't just start switching things at will. I need a fraction is equal to another fraction. Now, parts of that fraction could be ugly, right? Could be ugly, but in the end, as long as it's a fraction is equal to a fraction, I have some rules that we don't always get to stress. But other than that, have a good day. See you on the next video.